Hello and welcome to the Side One YouTube channel. My name is Ray, and in this video, the MR4 tank part 1, we're going to build up a small tracked robot. So all the parts that I've printed are now laid out on the table or the desk now. We have our tracks, our wheels. Now these are a geared wheel designed to drive the tracks or guide them along. Far end ones are the actual drives. It uses a pair of continuous rotation servos. These things just keep going in the direction based on... Oh look, there's a pot setting in there on this one. Based on the PWM signal you're sending to it. So they're like an ordinary servo in as much as you control it with the same sort of signal. But when the signal is not centered, it will drive in that direction continuously. The further off center you are, the faster it drives. This project was created by a guy out of the Sydney University. There will be a link in the description to all of the build files for this, the STL files, and it's actually not a bad little beginner's project. Now I've printed most of it in PLA. The tracks I printed in TPE. I wanted to see if I could grip a bit better with the more flexible filament. I'm using an Arduino Uno. One of the original types, and I've got this SaneSmart board. This board is designed to allow you to attach sensors very easily, but you can also attach servos to it very easily as well, and we'll take power in through the terminals up here if we need to. I've got this 6-volt battery pack still in its bag. It's actually designed for remote control applications. You'll need 8. Now these are 55mm long screws, M3. You'll also need 8 M3 screws that are, what are they, about 8mm long? 6mm long, and I've got these little screws. Now I can't remember the exact size of these. I'll look it up and put it in the list as well when I find out what they are. I've printed off the Arduino Uno bracket, so this mounts on like so. That's it. And those screws will go through the holes into the bracket and hold it quite nicely. This simply plugs in on top and gives us all of these plugs to connect onto. It also breaks out the I2C bus, etc., which could be handy later on. So let's get into building all of this. So just so we don't lose the small parts, I'm going to put in the drives for a start. So these were printed. They just push on, and then the original screw is used to hold it into place. And I had a screwdriver here a minute ago. Okay, so these are the servo mounts. And then we use the M3 screws to secure that into place. Now remember not to over tighten these, they are only into plastic. If you really wanted to, you could use longer screws, drill the holes through at M3 or 3mm and put nuts on the back. That too will work. Okay, that's the easy bits done. So the next bit we'll do is start to assemble the actual wheel assembly, or the wheel drive assembly. So we're going to take one of the body parts, in this case the front, we're going to take one of the joiner components, the front wheel section, and these just clip together. Actually they just push together. There's little pins on them that go into holes. And these go on like so. Now this is the non-drive end. We're going to make the back wheels the drive wheels. So we put one of these in, and then we put this cover on the end. And that allows that to spin freely. And now we take one of our 55mm long screws, and we put a nut on it. Okay, that's our front wheel on the left side completed. So let's do our back wheel. So for our back wheel, we need the servo drive. And it'll just clip on like so. We poke our wire through the assembly for the back. Want that to come out the top. Now we can put our wheel in. Line the square drive up and put the cover over. Now we can repeat for the other side. So we have our spacer block. We have our wheel. We'll put our other servo in at this time, because once we put in our other block it'll be a bit harder. So this will bind the two together. We can put our cover on over the wheels. This holds the wheel and allows it to spin. I think I cut these 55mm. You could probably get away with 50mm. These nuts are being a pain to start. Now we can install the back wheel and its cover. Okay, so that's got the basics of our motors and chassis assembled. You'll see the hole in the bottom here. This is actually for a line following sensor. So you can, I haven't got one of those here, but you can mount a line following sensor on there, draw a line on the ground and program your Arduino to follow the line. I've actually got other plans for this base, so I won't be setting up for line following. This front, and there are optional front ends for this, and amongst all of the files, this one's set up to take an ultrasonic sensor, HC04, and I may put one in down the track. I am planning on putting a HC04 on a servo mounted on top. For that I'm going to have to build another one of these mounts to hold another servo. But let's just get the basic robot going first. So these tracks all use a pin to act as a pivot point. This pin is just PLA, 1.75mm PLA. Most of these have got a transparent filament in them, but I've had a couple of pins break on this, probably because I had moisture get into that filament, and so I've had to replace two, one on each side, with the black. If you do break your hinges or wear them out, just replace them with more filament. Easy to get. Okay, so that's our basic mechanical build done. What's going on here? Now, normally this sort of setup you would connect between the ground and the in on the Arduino, or plug it into the barrel jack. And I'm still tossing up which way to go. I've also got this separate supply up here, and I might just cut the terminals off the end of this and put it into there. So that's one option I've got. In any case, batteries in and just drop it in the bottom for now. One of the add-ons that you could get was actually a holder that would hold a 9-volt battery pack, which I haven't built either, mostly because my servos won't run on 9 volt, and I didn't want to overload the power supply on the Arduino. So in the next video, I'll look at basic control after I finish connecting that up, and we may even look at the next piece to go on there that'll hold the next servo. So this is my ultrasonic sensor. It's a HC04 mounted in a custom frame to hold it, and that's just mounted onto a servo horn. That'll get mounted in like so, and it'll allow the robot to swing it back and forth to have a look around and survey the area. The purpose of me building this one is actually to study the simultaneous localization and mapping. ability of robots, or SLAM. So if we can get SLAM to work on a small scale robot, that's going to make life easier for my bigger robots. That'll do for this video. If you like these videos, don't forget to click on like, subscribe, ring that notification bell. It's a form of support, helps the channel a great deal and costs you absolutely nothing. If you'd like to help the channel further, I do have a Patreon account, and you can join my VIP patrons Go Lucky and Lorenz Berger, and my builder patron Al Morales 45 in helping to support the channel. They do get these videos early, and their support is greatly appreciated. If you have any questions, either leave a comment below or drop into Discord. There'll be a link in the description, and I can answer all of the questions you like through there as well. And we will see you in the next video.